Hi, welcome to the Math Lab differential equation problem solving section. So today here is the problem we're going to solve. It's 2x dy plus x squared y fourths plus 1 y dx equal to 0 with initial condition y1 equal to 1. All right, so let's go ahead and take a look at how do we do these problems here. So when we first look at it, and I typical I always like to do is try to put the dy dx in the same place, so I will be able to see anything I can find that is use the Bernoulli equation or not. So okay, so let's do this. So I will do 2x dy dx plus x squared y fourths plus 1 equal to y equal to 0. Then let's do so this is 2x dy dx. Now I do a distributive property and put this one in. So this will be plus x squared y fifths plus y equal to 0. So when I see this form, I see the y fifths, and the y prime. They are all in the linear form. So I think this possible will be a good candidate to use for the Bernoulli equations here. So the next steps here, what I will do, I will divide by 2x both sides here, 2x, 2x. Okay, so I will have a dy dx is equal plus x squared, so it will be 2 the x y fifths plus 1 over 2x y equal to 0. Okay, then I rearrange it so to match the Bernoulli equations. So I will have a dy dx plus 1 over 2xy equal to the x over 2 y to the fifth negative, right? So so this will be my px. So like we said before, this will be my px, this is my qx, and this is my n. So n is equal to 5. So this is me satisfy the Bernoulli equation condition. So I know I can solve this problem by using the Bernoulli equation approach. Okay, so the step number 1. So we always do is y equal to y1 minus n, so it's y the 1 minus 5, so it's y to the negative 4. Then take the dv dx, so it will give you negative 4 y to the negative 5 dy dx, or I can simplify this to negative 4 y to the fifth dy dx. Then the step number 2, okay, so the step number 2, we want to change the dy be a function of dv dx, dy dx. So the dy dx will be equal to just times the reverse constants here. So it's y to the fifth for negative dv dx, right? Okay, so after that, what I need to do, I need to substitute my dy dx. Let me highlight my equations here. So this is my original equations here. So substitute dy dx. So here this is negative y to the fifth for dv dx, right? So I try to replace here. I try to replace the dy dx with this, all right? So the dy dx equal to um, negative y fifth over 4 dv dx plus 1 to the 2xy equal to negative x over 2 to the y to the fifth. All right, so then I want to change it to the linear, the ordinary differential equation for v. So what I need to do is here, so I need to times both sides. I need to times the both side with 4. Okay, so it's 4. Okay, so times negative 4 and y to the fifth. So I times negative 4 y to the fifth. Okay, so then this one's here. The first term will be a dv dx. Then the second term's here, negative 4. So negative 4, so it will be negative here. So this one will be negative 4, so it's a 2 and x. Now here you will have y to the negative 4. And is equal to, then the negative 4, y and y cancel, 2, 2. So this will be positive 2x. Okay, so I also know my y negative 4, v is equal to y to the negative 4th, right? So I can change it to here. So the dv dx minus 2xv equal to the 2x. Okay. Okay, so now that's step number 4. After this, then this is the one first order differential equation, ordinary differential equation. So number 4, I'm going to find the integration factor. So it's du dx is equal to the negative 2x times u. Now I want to solving for u, right? All right, so here we can have the du over u equal to negative 2 the x dx. So I will have a natural log u equal to negative 2 the natural log x. And this one I can change it to the natural log 1 over x squared here. So I can get my u is equal to 1 over x squared. Okay, so after that, I can, so the next important equation is here. So after I find the integration factor, so this is the other ones here, right? So I need to multiply the integration factor to these equations here. So let's see here. So I will have u equal to the 1 over x squared, right? So let's see here. So it's 1 over x squared du dx minus 2 x cubed v. I'm sorry, this is dv dx, right? Then it's equal to 2x, so it will be 2 to the x. And then we did many times in my previous video, so we know this was here. So this one going to become the derivative of 1 over x squared V. So if you apply the product rule, right, you will get this integration. So it's 1 over x squared. So the V is dv dx. Then plus 1 over x2 is negative 2 to x3, right? So that's why it's here good. So it's equal to the 2x. All right. Then the next is here. It will be what is the step here? Step 4. Okay, so the next step here was step 5. Now we integrate both sides. Okay, so when I integrate both sides, as you can see here, it will be the dx 1 over x squared v equal to the 2 of the x dx. So here, this is the derivative and integrated by the fundamental theory of the calculus. So I know the left-hand side is 1 over x squared v equal to 2 the ln x, right? So ln x plus c is here. And now I have, so I can put this one, so will be the ln x to the square plus c. And so times x squared both sides. So the v is equal to the x squared ln. Since this is an absolute value, really doesn't matter. So it's x squared plus x squared. Then my initial condition y equal to 1. So I plug that in. So v is 1 over 4. Okay, so I will have 1. I'm sorry, here, this is cx, that's right, cx. So 1 is equal to 1 natural log 1 plus c. This one becomes 0, so c 1. So finally, we got our answers, right? So we said 1 over y fourth is equal to the x squared ln x squared plus x squared. Or I can say it's x squared, then ln x squared plus 1. So now the y is here will just be y fourth will just be the flip over. So this is x squared natural log x squared plus 1. Okay, so if you want to take the fourth power, or you can say this is my solutions here. All right, so that's it. And so for this one, just initially, when you look at the equations, and if you manipulate the equation and rearrange the terms, and then it turns out to be a very nice Bernoulli equation forms here. All right, I hope that this will help you. And so let's take a look at what, let's see you next time. Let's work on another problems here. All right. Okay, have a nice day. Bye-bye.